Okay, so for this transfer function, we have to construct the Bode plots for this. So to construct this, we're going to be using this table to help us out. It's recommended that you guys memorize this table, but for now, we're just going to be working with this. So first thing we're going to do is get these in terms of 1 first, okay? So it has to be JW times something plus 1 in all cases. So, well, to make our work much more simpler. So what we're going to do is do the following. We're going to factor out a 2 from our first one. So it'll be JW over 2 plus 1. And then for our second one, hold on, let me just decrease the size of this. Okay, there we go. So the next one, we'll factor a 10. So it'll be JW over 10 plus 1. So now we have a 2 here, we have a 10 here. Then we have JW over 2 plus 1. And then we have JW over 10 plus 1. So this is just 20. And that's 200 over 20, which is just 10. Oh yeah, sorry. 200 JW, so it'll be 10 JW all over JW over 2 plus 1 times JW over 10 plus 1. So for Bode plots, there's two types. There's there's a decibel versus angular frequency plot and a phasor versus angular frequency plot. So first, let's start by getting the decibel one. So what we do is do 20 log base 10 of all of this, and this is equal. If you remember your logarithms, this is 20 log of 10 plus 20 log of JW minus 20 log of JW over 2 plus 1 minus 20 log of JW over 10 plus 1. And so this is going to be equal to the magnitude decibels. Now to get the phasor, so we just obviously take the the imaginary components and divide it by the real components. So this one, the first one will be tan inverse. The imaginary component for this in here is 0 over the real component, which is 10. So this is just 0 plus 20. Plus tan inverse W over 1. So just W minus tan inverse JW2 over 1 minus tan inverse JW10 over 1. Okay, so tan inverse of 0, that's just going to be 0. So this is what our phasor is going to be equal to. So now let's start by drawing the Bode plot. So let's start with the, okay, so my one's not going to be exactly to scale, but I'll show you what the correct to scale one will look like. So for this one, well, the y-axis, it's pretty much going to be the decibel one. So all of these are in decibels for the y-axis, and for the x-axis, it's going to be represented by omega. So this is all just radians per second. But the thing is, this 20 is supposed to be our slope, but this slope is in something called decibels per decade. So decade pretty much means something that increases by a factor of 10. So if you go from 1 to 10, that's considered 1 decade. If we go from 10 to 100, well, that's considered 1 decade because increased by a factor of 10. So if we go from 1 to 100, then that's 10 decades because increased that's 2 decades because it increased by 2 factors of 10. So it had to be 10 times 10. So this is one decade, this is 2 decades. and that gives you 100. So I'll explain later on, like, what's how what this has to do with anything, because the 20 is not in decibels per radians per second, it's in decibels per decade. So we'll quickly get to that later. So let's start plotting this. So 20 log of 10, that's just equal to 20. So we'll plot this here. So we'll first dash all of this, and this will be 20 log of 10. Sorry, log of 10. Now, then we have 20 log JW. Now this is where we're going to be using our sheet here. So pretty much what we see here is that when we have JW, pretty much our slope should look like this, and pretty much it intersects at 1 because this is being divided by 1. R1 is being divided by 1, so it'll intersect at that point. If it was being divided by 2, then it would intersect at 2. Okay, so let's find the point. Oh yeah, and this starts at 0.1. Okay, this is 0.1, not 0. So because if you try and do log of 0, you get error. So that's why this is we usually set this to be 0.1. You could set it to 0.001, but let's set it to 0.1. And let's have this point be 1. So we'll have a dash going here, and then 1 going here, and it's minus 20. Okay, if this was 0.001, then it would hit minus 40. Okay, because obviously we would have to extend this more in that direction. Alright, so let's go back to what we were doing. So this represents 20 log JW. Now we have minus 20 log JW over 2 plus 1. So we see this one looks the closest to it. So we see at Z, which is whatever it's being divided by. So this one, Z will be 2 in that case. So at 2, it breaks up. Okay? So let's say this is 2. So, it's moving here, and then at 2, it breaks up. But notice, we have negative. This is a negative log. So we're actually going to be working with this one. Okay? Because in this case, n is to the negative. And then you just times it by that. Oh yeah, your power also matters. So if your power was 2, then your slope would be 40. Okay? So in this case, our thing is supposed to be going down. Okay? Okay, now what's next? Okay, then we have this one, minus 20 log JW10 over plus 1. So this one, let's find 10, and it's going down. So this one is minus 20 log JW over 2 plus 1. And this one is minus 20 log JW over 10 plus 1. And these are obviously moving on and on and on. So let's also pinpoint the slopes. So this has a slope of 20 decibels per decade. This has a slope of minus 20 decibels per decade. And this also has a slope of minus 20 decibels per decade. So notice the x-axis is in radians per second, but we're doing it all over decades. So that means we would have to work with decades here. Okay, so if we go from 2 to 10, so like pretty much when we're trying to find the slope, like obviously it's y2 minus y1 all over x2 minus x1. Obviously, we're not going to put 10 minus 2 for this case. We're going to put them in decade form. So to put it in decade form, you do log base 10 all over 10 over 2. This gives you the decade of from 2 to 10. So 10 divided by 2, log of that is 0.6989. So that's how many decades separate 2 and 10. Okay, so enough about that. Now our Bode plot is pretty much going to be the sum of all of this. Okay, so let's start drawing our Bode plot. So we see at point 2, wait, okay, so from 0.1 to 2, we only have this and this to combine. So let's start from where we should start drawing our Bode plot. So we see this line's at 20, this line's at minus 20. So add them up. We 20 minus 20, that's 0. So we're going to start a Bode plot at y 0, or HDB at 0. Now we see this has a slope of 20, and this has a slope of 0. So this thing is going to have a slope of 20 all the way until we hit 2. Okay, and we can actually find out the point at this region. What we do is pretty much y squared minus y1 all over over x squared minus x1 equals the slope. So we know what the slope is, 20. We know our our x values. It's log, so 2 over 0.1. So log of 2 over 0.1, that's 1.08, this is 1.3010. Okay, that's good. And our y1 was 0. So y2 will be this point, and we get that to be equal to 26.02. So it stops at 26.02. Then notice here, so when we're at this region, we have to take now this line into account, but this line is still continuing. Remember, this line has a slope of 20. This line has a slope of minus 20. Add them up, we got 0. So that means our graph now should be moving straight until we reach 10, because now we have to take into account this line. So when we hit 10, we're now here. We're still at 26.02. Our graph didn't move up or down. But so now when we're here, we have minus 20. But this graph is also still continuing downwards. This one is still continuing upwards, but they cancel each other out. But then we have this minus 20 slope here. So that means this thing starts going down minus 20. And that's your Bode plot. Sorry, hold on. And yeah, pretty much that's your Bode plot for the decibels versus radians per second. Now let's do our degree one. So our degree is going to be in phasor versus radians per second. Okay, so let's start for that one. Our phasor one, we're gonna base our information. Oh wait, I made a mistake. This should be W over 2, not JW. Okay, we take the number being times by the imaginary component. My bad. Anyways, so remember, this is related to this one. This is related to this one. This is related to this one. So we're gonna use the value from here to get our to determine our phasor point. So tan inverse W, that's related to 20 log JW, and we see 20. So when it's in JW format, our thing has to be at 90 degrees always. So for the first part, it's going to be, let's call this 90. So this is going to be represented by tan inverse W. Okay. Now the next part is minus tan inverse W over 2. That's related to this portion. And we see, and it's minus. So we have this one. And we see that it would go from point P, which is whatever's being divided by JW, over 10. And so it'll be at 0 at that point, 0 degrees, and then moves all the way down to minus 90 when when point P is times by a factor of 10. So for for this one, P is 2. So what we're going to do is do 2 divided by 10, which is 0.2. So we'll do 0.2 here, and then 2 times 10, that's 20. So what we're going to do is put 20 here. We have minus 90 degrees. So this one, it goes from here, breaks down until we hit this point, and then starts going this way. Okay, so that looks good. And this is going to be representing minus tan inverse W over 2. Now the next one, same thing, but so we have minus tan inverse W over 10. This is related to this. So point P is 10. So 10 divided by 10, that's just 1. So we'll put 1 here. 10 times 10, that's 100. Okay? And, oh yeah, and by the way, the power also matters, whatever it's being to the power of. So right now it's to the power of 1. So we times 90 by 1. Whatever was to the power of 2, then we would times 90 by 2. So it'll be 180. So that's why, we have these ends here. That's what it's being times by. Okay, so the next one, it goes to 1. Then it goes down to 90. And this one is also is minus 10 inverse W over 10. Okay, now the next part we're going to do is get the slope. So we already know the slope of this is just 0. Let's get the slope of this and this. So for this one, so let's see, it's y2 minus y1 over x2 minus x1. So y2, 0 minus 90 all over 0, 0.2 minus 20. Let me see what that gives me. Wait, sorry. Remember, I made a small mistake. Remember, the slope is over decades, so it's not 0.2 minus 20. It's actually the following. There we go. So let's see what that gives me. That gives me minus 45 degrees. So this has a slope of minus 45 degrees per decade. Now the next one, it goes from 0 to 90 again, all over log of 1 over 100. And let me get the slope for this one. So it'll be this one is also minus 45 degrees per decade. Okay, so that's good. So we're gonna put that for that one. All right, now we're gonna be drawing our Bode plot for the phasor one. So we see at the beginning we have 0 here plus 90. So our Bode plot starts here. We have our first change at 0.2. So we'll stop at 0.2. And remember, this is 0.1. Okay. The x we're starting at 0.1. So when we hit 0.2, we have this minus 45 degrees here. So minus 45 degrees per decade, the angle, sorry, the slope plus a slope of 0. That means this starts going down at a slope of minus 45 degrees per decade, and it continues that until we reach 1. Then we have to add this slope to it. So minus 45 plus 45. Minus 45 plus minus 45, that's minus 90. So it has a slope of minus 90. Let's also find the point. So let's find the point of this to here. So what we will do is do y2 minus y1 all over log of 1 divided by 0.2. That's going to be equal to minus 45. So y2 minus y1 all over, hold on, 0.6989 equals minus 45. And y1 is 90. So times all of that. And isolate for y2 will be 58.546. So that means at this point, 58.546, we're here. And then we continue decreasing by minus 90 degrees. And until we hit 20, because then this has a slope of 0. So let's find where we should stop for that. So let me erase all of this. So now we're from here and we're trying to find our next stopping point. So we know it's going to stop at 20. So it'll be y2 minus y1 all over log of 20 over 1 equals minus 90, with y1 being 58.546. And our stopping point for y2 is going to be minus 58.546. So somewhere here. So we continue moving all the way down until we reach here. And then our slope is now minus 45 degrees because that's the only slope fact playing out here. And it goes all the way until we hit 180. Sorry, minus 90 degrees. And then after that, our slope is 0, so it just continues off at 0. Okay? And yeah, that's pretty much your